All right, if you're building anything with AI, there's this one concept you've absolutely got to get right. Or, well, it's just not going to work. It's called generalization. And it's basically the secret sauce for making models that actually function out there in the messy, unpredictable real world. So, to really wrap our heads around this, let's kick things off with a kind of weird question. Seriously, what could an alien possibly teach us about AI? But stick with me here, because it turns out this little thought experiment, it's the perfect way to understand one of the biggest, most common tripwires in all of machine learning. Okay, so picture this. An alien visitor lands on Earth. They're super excited to explore, make new friends, the whole deal. But there's a big problem. Their fancy universal translator, it's on the fritz. Busted. So if they want to connect with anyone, they've got to learn the local language, completely from scratch. So our alien visitor hatches a plan. They think, okay, I'll just immerse myself in one small, really tight-knit community. And for months, that's all they do. They just listen, soaking up the language directly from the locals. I mean, on the surface, that sounds like a pretty solid strategy, right? What could go wrong? So, after months of this, our alien feels confident. They're ready. They step out into the wider world, walk up to someone, try to start a conversation, and nothing. Just blank stares, total confusion. So what happened? Their language skills, which seem so perfect in that little community, completely fail to work in the real world. And that failure, that right there, is exactly what we need to talk about when it comes to AI. You see, our alien's big fail is a perfect, and I mean perfect, illustration of a classic problem in machine learning. It's called overfitting. And it's the reason why a model can look like an absolute genius during training, getting everything right, but then just completely fall apart the second it has to face the real world. So let's break this down. The alien's training data, if you will, was just that one small group. They didn't just learn the language, they mastered all the local slang, the weird inside jokes, all the little quirks. But the moment they faced new, unseen data, literally anyone else from outside that group, all that super specialized knowledge became totally useless. And that is the heart of overfitting. The model isn't really learning, it's memorizing. It memorizes the training data so perfectly, including all the random noise and weird quirks, that it can't see the bigger picture anymore. And here's the really dangerous part, the thing you have to remember. A model can get a perfect score, an A+, on its training data, and still get a big fat F in the real world. Okay, so our alien realizes their mistake. They realize they overfit to that one little group. So they go back to the drawing board. This time, the strategy is going to be totally different. It's not about depth anymore. It's all about variety. And you can see the huge shift right here. On one hand, you've got the flawed approach, a small, uniform data set that just teaches quirks and jargon. But the successful approach, it uses broad, varied data. And that's the game changer. It forces the model, or, our alien, to look past all that noise and actually figure out the core, fundamental patterns of the language that work everywhere. Now, this is what we're talking about. This is successful generalization in action. When you train on a data set that's really diverse, the knowledge becomes robust. It becomes flexible. It's that variety that gives a model the tools it needs to handle the unexpected and still perform well, even in situations it has never seen before. So if we look at the solution side of this, the difference is just night and day. The training data is no longer one tiny group. Now it's a mix of everything: formal news reports, street slang, casual conversations, you name it. And by learning from this rich, varied pool of information, our alien can finally see the real core patterns. And now they can communicate effectively no matter who they're talking to. So, okay, how do we actually do this? How do we make sure our models generalize? Well, it really boils down to three key things. First, your training data has to be as wide and varied as the real world you're sending your model into. Second, you have to help the model find the real patterns, the signal, and not get distracted by the quirks and the noise. And maybe most important of all, you have to remember the real test isn't how well it does on the data it's already seen. The real test is how it performs on brand new data it has never, ever encountered before. And this right here is why generalization is so unbelievably important. Seriously, if you're building anything with AI, this isn't just some nerdy technical detail. It's the whole game. It is the bright, shining line between a cool tech demo that only works in the lab and a real product that people can count on to deliver actual value, day in and day out. Here's another way to think about it. An overfit model is like a student who didn't actually study for the test. They just memorized the answer key for one version of it. The second you change the questions, even a little bit, they're totally lost. But a model that generalizes well, that's the student who actually learned the material. You can throw any question at them because they understand the core principles underneath it all. Look, at the end of the day, the goal is to build AI that doesn't just work in the lab, but actually thrives out there in the real world. So, if you're ready to go deeper and learn more strategies for building AI products that really work, I can't recommend the AI Product Management Playbook enough. Go ahead and subscribe to keep learning. Thanks so much for joining me.